Alright, the last section that we are going to look at is going to involve solving some more application problems. In order to do this section, you do want to understand the key terms and phrases and how they translate to mathematical operations. You want to be able to understand how to solve a system of equations using substitution or elimination method. Okay, let's go ahead and look at a couple of more examples that involve systems of equations. These are not considered classic problems like the perimeter of a rectangle, the mixture problem, the investment problem. Those are considered classics, but these are still examples of systems of equation problems. Now for this first one, I would like it noted that I did not write this problem, and it is very wordy. But let's go ahead and read through it and see what we can go ahead and do with this. So it says, cholesterol intake should be limited to 300 milligrams or less each day. Altogether, 2 McDonald's Quarter Pounders and 3 Burger King Whoppers with cheese contain 520 milligrams of cholesterol. 3 Quarter Pounders and 1 Whopper with cheese exceed the suggested daily cholesterol intake by 53 milligrams. Determine the cholesterol content in each item. Okay, so don't ask why we're only eating hamburgers. I don't know. It's the one thing that baffles me about this problem. But let's go ahead and see what we can do in order to solve this. This problem is relatively easy to set up because we do have one sentence for each equation. So again, the first thing I want is I'm going to let x be, actually let's go with m. Let's let m be the amount of cholesterol. In a quarter pounder. And let's let b equal the amount of cholesterol in a Burger King Whopper with cheese. Okay, so we have, it says 2 McDonald's Quarter Pounders and 3 Burger King Whoppers with cheese contain 520 milligrams of cholesterol. So what can we do in terms of the equation? Well, this is going to be 2m plus, that's our 2 McDonald's Quarter Pounders, and 3b, that's going to be our 3 Burger King Whoppers with cheese. And together, they contain 520 milligrams of cholesterol. Okay. Our second equation, we have 3 Quarter Pounders and 1 Whopper with cheese exceed the suggested daily cholesterol intake by 53 milligrams. And remember that the intake is 300 milligrams. So first part of this, we have 3 Quarter Pounders, 3 McDonald's Quarter Pounders, and 1 Burger King Whopper. And if we're going to exceed the daily cholesterol intake by 53 milligrams, that means it's more than 300 milligrams. So this is going to equal 353. We take our 300, which is our limit or our suggested daily intake, and we want to add 53 onto that. So here is our model. And now we want to go ahead and solve this. So this one you can set up using either substitution or elimination, it doesn't matter. I'm going to go ahead and use elimination for this one. And the easiest variable to eliminate is probably the b's. So we're going to go ahead and multiply the second equation by -3. Remember, we want our coefficients to be the same, and we also want them to have opposite signs. So my first equation will stay the same. It's going to be 2m plus 3b equals 520. And my second equation, if we multiply by -3, I get 3 times -3 is -9m. -3 times b is just -3b. And finally we get 353 times -3 is -1059. We can go ahead and add straight down. We get -7m. My b's cancel. Equals -539. And if we divide by -7, we get m is equal to 77. And we're done finding m. So from here, to figure out b, we want to take this number, plug it back into an original equation. I'm going to go with the second one. Looks a little bit easier. And if we plug in 77, we get 3 times 77 plus b equals 353. 3 times 77 is going to be 231 plus b equals 353. And if I subtract 231 from both sides, I get b equals 122. So, a McDonald's quarter pounder with cheese, or just quarter pounder, contains 77 milligrams of cholesterol and a Burger King Whopper with cheese contains 122 milligrams of cholesterol. And we're done. So hopefully this is a little bit easier to translate. And it's just a matter of reading through, again, determining what you're looking for, and trying to figure out how to translate the given information. All right, let's look at a couple more. The next one that we have, you just purchased a rectangular waterfront lot along a river's edge. The perimeter of the lot is 1,000 feet. To create a sense of privacy, you decide to fence along 3 sides, excluding the side that fronts the river, the scenic Rio Grande. An expensive fencing along the lot's front length costs $25 per foot, and an inexpensive fencing along the 2 side widths costs only $5 per foot. The total cost of the fencing along 3 sides comes to $9,500. What are the lot's dimensions? So for this one, let's go ahead and draw a picture just to kind of get an idea of what this looks like. So we have our river, and we have our lot that looks like this. All of the purple is going to be where we're going to fence. So the first thing that we have is the perimeter is 1,000 feet. For this, we're still going to use our perimeter formula. So remember, your formula for perimeter is 2L plus 2W equals, and here we have our perimeter is 1,000. Okay, so for the next statement, it says to create a sense of privacy, you decide to fence along 3 sides, excluding the side that fronts the river. It says that we are going to use a expensive fencing along the long side, the front length. That costs $25 per foot. And then along the 2 side widths, it says that we are going to use something that costs only $5 per foot. So the side widths, this is $5 per foot. $5 per foot. And we have the total cost of the fencing along the 3 sides comes to $9,500. Okay, so we still have that our length, and we want to know how much money are we going to spend on the fencing along the length. Well, that's going to be 25L. Now, for the width, you may want to sit there and say, okay, well, it's going to be 5W. But it's actually not, because notice that we are doing it twice. So we are actually going to end up spending $10 per foot along the width. We're going to spend $5. For every $5 that we spend here, we're going to spend another $5 over here. So we want to add our 2 5s together to figure out how much we're going to spend on that side, or on the side widths. If we add these 2 costs together, we get our total cost, which is $9,500. And now we have our model. So for this one, this is also a good example of something that would be best solved using elimination method. So I'm going to go ahead and eliminate my W's. Those are a little bit easier to work with. So I want to multiply my top equation by -5 in order to get to 10. So if we multiply every term by -5, we get -10W, -10L, minus 10W equals -5,000. My second equation stays the same. And if we add straight down, we get 15L. My W's cancel, equals 4,500. I can divide both sides by 15, and we're left with L equals 300 feet. Okay, so now let's go ahead and figure out what W is. So we're going to take this and plug it back into one of our original equations. It doesn't matter which one. If we plug it into the top one, we get 2 times 300 plus 2W equals 1,000. 2 times 300 is 600 plus 2W. We still have equals 1,000. I can subtract 600 from both sides, and we get 2W is equal to 400. if I divide by 2, I get W is equal to 200 feet. So my final answer, remember that we want to know what are the lot's dimensions. And so the lot's dimensions, we have the length is 300 feet and the width is 200 feet. And we're done. So hopefully that one makes a little bit more sense. Okay, I think we've got 2 left to go. Okay, now that we have fenced our lot, we're going to build our house, and we are going to be considering 2 different heating systems. So the cost for 2 different heating systems are given below in the table. We have solar, which costs $29,700 to install and $150 per year to operate. We have electric, which costs $5,000 to install and $1,100 per year to operate. We want to know, after how many years will the total cost for solar heating and electric be the same, and what will be the cost? So I'm going to start with my variables. We have how many years is one of them, so I'm going to let T equal time in years. And we also have cost. So I'm going to let C equal the cost. Okay, so let's go ahead and set up some equations. So for here, our 2 equations, we have the cost for solar. So my solar equation is going to be C equals 150Y T plus 29,700. Okay, why is that? Well, we need to multiply the 150 by however many years we're running this. Now the cost to install, this is a one-time fee, so it's a constant. So that is our first equation. Our second equation is electric, and our cost for electric is going to be 1,100 T plus 5,000. Same idea. Since it's $1,100 per year, I want to multiply it by the number of years. And again, the installation cost is a fixed number. So these are our 2 equations. So the easiest way to solve this is substitution method. We don't have our variables lined up very nicely in order to do elimination. And so what we can do is take our 1,100 T plus 5,000 and plug it into the other variable in the other equation. So I'm going to have 1,100 T plus 5,000 equals 150 T plus 29,700. Does everyone see how I got that? So I took this and plugged it in up here. Okay, so now we can go ahead and solve this. So to solve this, I want to get all of my variables on one side. I'm going to subtract 150T from both sides. We get 950T plus 5,000 equals 29,700. I can subtract 5,000 from both sides, and I get 950t equals 24,700. From here, we want to divide by 950. So go ahead and use your calculator to figure out what this is equal to. Dividing both sides by 950, I get t equals 26. So what does that mean in terms of the problem? Well, that means that in 26 years, the cost will be the same, and now what is that cost? So if we take this and plug it back into one of our original equations, let's say the second one, we get C equals 1100 times 26 plus 5,000. That's going to be 28600 plus 5,000, which is equal to 33,600. So to finish this off, that cost will be 33,600. One of the things to note about this is when you get into some higher level math classes, depending on what you're going to be doing. If you're going into a business field, one of the things that we do is we call this a break-even value. A break-even value is when they're equal, meaning that it doesn't matter which one we go with. And break-even values, the only reason that we want to know the break-even values is, again, back to our inequalities, is which side would be better to pick. So here's a question for you. If you live in the house for less than 26 years, which one is going to be the better deal for you? Well, electric is going to be the better deal. If we live in the house less than 26 years, the cost of electric will be less than the cost of solar. But on the other hand, if we live in the house for more than 26 years, then the cost for solar will be cheaper in the long run. So it's a matter of short run versus long run values. So as I said, if you're going into business fields, this is something that you will discuss a lot in terms of what is best for your business. Which one are you going to make a profit with based on certain criteria? All right, so that takes care of the little side note on that one. So let's go ahead and look at the last example that we have. So we have built our fence, we've built our house, and now we get to enjoy our property. And so what we have is Ellen and Kent are going to canoe down a river 18 miles in 3 hours. And on the return trip, they can only get 12 miles upstream in 3 hours. We want to find the speed of the canoe in still water, and we want to find the speed of the current. So the first thing that we need is, I noticed that we have distances, we have rates, and we are told, we have distances, we have times, and we are looking for rates. So that tells me that I want my distance formula. And my distance formula is D equals RT. This is going to be the one that we want to work with. The other thing we have is we have our variables. So I'm going to let B, I don't like talking about it in terms of a canoe. I like calling it a boat. This is going to be the speed of the boat. When we say in still water, that means take it out of the river, put it in a lake where nothing's affecting it, and how fast are they actually paddling by themselves. And I'm going to let C be the speed of the current. Okay, so now we have our distance formula, and we're going to be looking at two different equations again. My first equation is, let's look at downstream. So downstream, we have our distance is 18. We'll come back to the rate, but we do have that t is equal to 3. Remember that t is our time. We also have upstream. We have is 12. We'll come back to the rate. And again, we have our time is 3. And so now we want to talk about the rate. So real fast, if we were to draw this, we're going to have our boat, and we're going to be going this way. And here's the thing, we want our river or our current, our river, to be going the same direction. Now keep in mind that we're not going to paddle less because the current is doing some of the work. We're paddling the same rate no matter what. Well, if we're both going the same direction, then what we want to do is add our rates together, and that will be the total rate of how fast we're traveling. On the other hand, if we are going upstream, then we are going against the current. If we're going this way and our river is going this way, we're actually going to be traveling slower. And so what our rate is going to be is basically we have the rate of our boat, but the current is pushing us further back. And so our rate is going to be B minus C. Now, one of the important things to note on this, make sure that your vehicle, your boat, your bike, your plane, whatever it is always first. Otherwise, what you're going to get is your vehicle is going to be going slower than your canoe. And in this problem, we do want to actually make it upstream. We don't want to be paddling and being pushed backwards. So, make sure that you do have your answer in the end. Make sure it does make sense in the context of the real world. Okay, so now let's go ahead and solve this. Now there's two ways that you can solve this problem. The first thing that we could do is we can distribute, and we get 3b plus 3c is equal to 18. We also have 12 equals 3b minus 3c. We can solve from here, and note that this is an elimination problem because we already have that our c's are going to eliminate. So if we add straight down, we get 30 equals 6b. As I said, my c's cancel, and from here we can divide by 6. So we get 5 equals b. Okay, that's fine and all, but another thing that you can do is, instead of distributing, is I can divide both sides of my equation by 3 so that we get 6 equals b plus c. Same thing on the second one. We can divide by 3. We get 4 equals b minus c. Now in terms of the first part of this, in terms of solving for the first variable, it doesn't matter because it's going to involve the same thing. So note here, if we add straight down, we get 10 equals 2b. My c's still cancel, and we can divide by 2. We get 5 equals b. But for the second part of this, to find c, it is a little bit easier to work with these equations here as opposed to these ones over here. So if I plug in 5 into my top equation, I get 6 equals 5 plus c. And in order to solve for c, I subtract 5 and I get 1 equals c. Whereas if we had plugged this into the ones on the left, we would have had to multiply, subtract, and then we would have had to divide. But ultimately, it's up to you in terms of what makes more sense. So now, the last thing that we need to do is go ahead and interpret our results. So we have the canoe or the boat, however you want to label it, is traveling 5 miles per hour. This is a rate, and the current is 1 mile per hour. And we're done. As I said, make sure that your vehicle is always moving faster than your river. Otherwise, you are going to be paddling upstream but going downstream, and we don't want that. It is implied that they are going to make it upstream. Okay, so hopefully that makes a little bit more sense. I understand that this is probably going to be a section that we need lots of practice on, and so I'm going to ask that you go ahead and try these problems on your own. Be patient with yourself. If you're not sure, we will go over these in class, and we will try to hash out more details about them, okay? Word problems are always problems that students struggle with, so please take your time, be patient with yourself, and again, if you don't understand, it's okay. We'll get through it, all right? In the meantime, try these problems on your own. See what you can do with them, bring them, as well as any questions that you have to class. The last thing, please go ahead and answer the following questions. How confident are you with the material presented? What from this section and the previous lecture needs to be explained further? And how much more practice do you need to be relatively comfortable with the topic?